Good morning, everyone. I'm presenting the background of a project titled Proposed Construction and Completion Using Industrialized Building System for 103 Units of Double-Story Detached Houses. The project is located in Kampung Datu Baru, Cebu, and it's a collaboration between LCDA, a government-linked body, and Real Estate Sdn Berhad, a private developer. The goal is to use industrialized building system (IBS) to construct modern homes more quickly and efficiently. IBS allows for faster assembly, building quality control, and reduces reliance on manual labor and material waste. The project aims to deliver sustainable and space-efficient housing while setting a new standard for IBS use in Sarawak. This project brings together several key professionals, LCDA and Real Estate Sdn Berhad as the main client and project drivers, FV and Amanda Lau as the architects responsible for design and layout, and the consultant provided civil and structural engineering services. Perunding Kenyit managed the mechanical and electrical works. Juru Ukur Bahan CWC acted as the quantity surveyor, handling budgeting and cost control. This multidisciplinary team worked closely from planning to completion to ensure the project meets safety standards, design goals, and financial targets. The site is in an accessible urban location, but Sarawak's frequent rain poses risks to construction progress. By using IBS, the team reduced weather delays through off-site precasting and on-site assembly. The double-story design maximized space with living areas downstairs and bedrooms upstairs, balancing function and comfort. At the time of tender in July 2021, the industry faced COVID-19 impacts, rising material costs, supply chain issue, and labor shortage. IBS helped address this by limiting on-site work and improving cost and schedule control. Overall, the project demonstrates smart adaptation to market and environmental challenges using modern construction methods.
Assalamualaikum sir. So for my part, I will be explaining the Form 1 of the ECA form. So the job title for this project is Proposed Construction and Completions Using Industrial Building System for 103 units of double-story detached houses on Block 2, Cebu Town District at Kampung Datu Baru, Cebu, Sarawak. So the location is Cebu, Sarawak. So for the information total project, the project details and site conditions, the construction and completion of IBS double-story detached house for 103 units. There is very good access to site, and overall the site generally flat and ready for construction. So for the building type and code for this project is number 8, which is residential building. Below this is the houses of the project, which is A to 150. It should have been 122, but I don't know, maybe there's a technical issues on the Excel. So A is the material used for the frame, which is reinforced concrete. 2 is the number of story for the building, which is 2 story of the detached house, and 150 is supposed to be 122 is the GFA of the house. So moving on to the contract particulars for this project. They use PWD 203A, and the tender they use bill of quantities negotiated. So the numbers of tenders issued from the client is 5, but the but they receive only 4. So this is the competitive tender list. The first one is 22.7, the second one is 22.8, and the third one is 23.5 million. So for the contractor for this project, they won by 21.4 million. Okay, so for the design and shape informations, since this is the detached house, so it has living room, dining area, kitchen, 3 bedrooms and 2 bathrooms and others. The ground floor areas for this house is 61.19 meters square. For the first floor is 60.32 with a total of 122 for the gross floor area. So if we count it usable area which is 104 meters square, and the circulation area is 17 meters square, which also come up with a total of 122 meters square. The functional unit, which is equal to the usable area, which is 104 meters square, and this is the percentage of gross floor area based on the floor. So ground floor took 50.36%, while upper floor took 49.64%. So for the last part, for the Form 1 of the ECA is brief cost informations. So the contract sums is 21 million. The provisional sums is 650 million. This project don't have the Franco sums. The prelims for this project is 723k, and with the being 3.37 remainder. The functional unit costs is 8,000 per meter square usable area.
Hello everyone, today I will briefly present the elemental cost analysis form 2 for a proposed housing development project in Kampung Datuk Baru, Sibu, Sarawak. This project involved the construction of 100 double-story detached houses using the Industrialized Building System (IBS). Each house has a gross floor area of 122 square meters with a contract sum of 21.48 million. Let's look at how this cost is distributed by building elements. First, the substructure includes piling and groundworks totaling 42,000 ringgit Malaysia or about 708 ringgit Malaysia per square meter. Second, the superstructure is the largest cost segment at 87,000 ringgit Malaysia, accounting for key components like frame, floors, walls, windows and doors. Next, we have finishes including wall plastering, floor scripts and ceiling treatments, totaling 38,000 ringgit Malaysia or RM646 per square meter. For fittings and furnishing, mainly plumbing and sanitary items, the cost is 5,500 ringgit Malaysia, a relatively small portion. The services section is significant with plumbing and electrical installation contributing a combined RM673,000 ringgit Malaysia, representing over 500 ringgit Malaysia per square meter, largely due to M&E systems. Additionally, external works like drainage and site preparation cost 9,000 ringgit Malaysia and preliminary general construction overhead at 700,000 ringgit Malaysia. In total, the unit cost per usable square meter is approximately 1,000 ringgit Malaysia, which is useful for benchmarking against other projects. In conclusion, the superstructure and services dominate the cost, highlighting the impact of structural system and M&E services in modern IBS-based housing.
Okay, now we will move to the form 3, which is the form 3 is basically the last form for the ECA. So for Form 3, it doesn't involve any calculation, not like Form 1 and Form 2. Form 3 basically is where it stated the specification for each element for the purpose building. Okay, so Form 3 are divided with two columns. The first column is that the element of the structure, and the second column is where it state the specification of the elements. This specification can be get from the drawing and the BQ.
Hello, my name is Nur Christina and I am here to conclude our presentation. So this elemental cost analysis has helped us better understand how construction costs are organized and managed in a real project. For this report, we analyzed the proposed construction of 103 double-story detached houses in Cebu, Sarawak using the RISM standard format. We broke down the cost of each element, including the structure, finishes, services, and fittings, and learned how each one affects the total project cost. The use of industrialized building systems, or IBS, also showed us how modern construction methods can help reduce site labor, minimizes delays, and improve cost efficiency. This type of analysis is very helpful for clients, especially when there are budget limits, because it shows where adjustments can be made without affecting the overall quality of the project. Overall, this task gave us practical skills in cost planning and helped us see the important roles of quantity surveyors in giving advice, managing expenses, and supporting better decision making on real construction projects. That is all from us. Thank you very much.